Okay, today we're going to do dilutions. I'm using this app on my iPad for the first time in a while, so sorry if it's a little bit messy. If you guys could please all pull out your homework packet first. There were a few things that I think with how you guys have had to learn this lesson via pencast and not many people in the room with you, there's a few things I'm going to have you not do, and they're not going to show up on your quiz. So again, if you could get out your homework packet, you can pause the video here if you need to, but I'm not going to have you do number 4. Okay, you will learn that in a later unit. And then if you flip over, I'm not going to have you do number 7, 9, 12, 13, and then in the very back there, number 37. Numbers 9 and 10 you'll definitely get to. Those are the ones that on the lab on the back of that simulation. You'll do those with a teacher when you get that one in there, or when you get one in there. So those two especially you will do at some point, but those will not be checked on your homework. And then same thing with 12 and 13, you will hit those as well with a teacher that comes in here very soon. So the last thing that we need to cover for this unit is dilutions. It should be very quick here to cover. You guys have seen dilutions before, whether you realized or not. They were called dilutions. What it means to dilute something is it means to make it less concentrated by adding more water. Okay, so the big thing that you want to write here after I get this definition down. So less concentrated by adding more water. If I were you, I would highlight the less concentrated part. That's the most important part. And you can see this happen a lot. So I gave an example here of what it looks like if you're making something like Kool-Aid, where you put the water in and then you put the 2 cups of sugar in there, and let's say you taste it and it's way too sugary. Then you add more water to make it diluted, to make it more diluted. Now you can see, if you have a solution with color in it, you can see that happen because it becomes a lot lighter from adding more water in. Okay, so sometimes you can see. Now obviously if it's a clear solution, you can't see what it looks like when you dilute, but we do get to see that with colorful solutions. Now the main thing that I want you to realize from this dilutions picture here is that you are adding more water, but you're not changing the amount of sugar, right? The amount of sugar did not change at all. Now, when we work with solutions, we're not always working with sugar, of course, but when we're saying that our amount of solute, or our amount of stuff, did not change, we can instead say the moles, right? We put in a certain amount of sugar to start to make that Kool-Aid, and then when we added more water, we didn't add any more sugar, so our moles of Kool-Aid stayed the same. The fact that moles stay the same is the reason that we can use the dilution equation. Okay, remember to pause this at any time if you guys need to catch up on writing a few things. Okay, so since the number of moles stay the same, we can use this equation, and you'll use this equation a lot. M1V1 is equal to M2V2. So the molarity of the first substance times the volume of the first substance, or the initial substance, so molarity times volume, is equal to molarity of the second substance times the volume of the second substance. In this case, it doesn't matter whether volume is in milliliters or liters. However, since for the molarity equation, the one that is molarity is equal to moles divided by liters, since it does matter that that one is in liters, I always change my volumes to liters. I don't like to have to think about when it's okay and when it's not okay. So go ahead and write down this problem and see if you can solve for the volume. So it says for a lab, 300 milliliters of 0.15 molar HCl is needed. If I have a 2 molar solution, SOL apostrophe N is just the way that we abbreviate solution. What volume of it do I need? Okay, go ahead and write that down. I'm just rewriting it here on this page so that I can write over it. Okay, so when I go through and read this, it says for lab 300 milliliters, and you'll notice this. I even do this on my key. I kind of write it down as I go. I put 300 milliliters is V1, 0.15 molar is M1, 2 molar is M2, and the volume is what I'm looking for. So I just plug all of those things in and solve for a variable. Remember, I'm sure you guys were taught this at some point. If I did want to make that 300 milliliters into liters, I need to just move my decimal 3 places and make it 0.3 liters. So that's why I put 0.3 liters there. Okay. Last thing, tomorrow your homework is due. Of course, except for those questions that I told you didn't have to do. Tomorrow, after you turn in your homework, of course, the keys to the homework and the practice test will be on my website, or the practice quiz. Sorry, I'll give you a practice quiz, and then your quiz will be on Monday. Okay, we should be there with no problem. It's just going to be a quiz, 1 or 2 dilution problems, 1 or 2 molarity problems, a solubility chart, and then just the basic stuff from the very front of your homework packet where you have to draw something splitting it into its ions. I'll leave everything up on my website, especially the keys and then any of the pencasts in this video in case you need to look at them again. Thank you guys for being so patient and working with me here on this unit.